Hello everybody, it's Amell, and today I'm going to teach you how to solve the power of 2 problem. Given an integer, write a function to determine if it is a power of 2. Example 1, the input is 1. The method returns true because 1 is a power of 2. 2 to the 0 equals 1. Example 2, the input is 16. The method returns true because 16 is a power of 2. Explanation, 2 raised to the 4th power equals 16. Example 3, the input is 218. The method returns false because 218 is not a power of 2. How can we solve this problem? Well, we can solve this problem by taking advantage of a property of the binary representation of the powers of 2. So if we pay attention to the binary representation of the powers of 2, we can see this. This is the decimal representation, and this is the binary representation. And notice that the powers of 2, you can see that they always have exactly 1, 1 in the binary representation. So 1 in binary is 1, 2 in binary is 1, 0, 4 in binary is 1, 0, 0, 8 represented in binary is 1, 0, 0, 0, 16 represented in binary is 1, 0, 0, 0, 0. So you can see that they always have this property. So the leftmost digit in the binary representation is always a 1. So one way to solve the problem is to count the number of ones in the binary representation. And then we make sure that there's exactly 1, 1. If that's the case, this is a power of 2. So this is going to be the first solution. And I also made a video previously. The name of the video is number ones, and in that video I explained how to count the number of ones in the binary representation of a number. After this, I'll show you another solution that is more concise and more efficient than this one. But first, I'll show you this one. So first, I'm going to have a variable, integer count, gets a value of 0. Then while n is greater than 0, I will say count plus equals n bitwise end 1, and n logical right shift equals 1, and then I return count equals 1. So as you can see, what I'm doing is counting how many ones there are in the binary representation of the number n. Then by the end, count has the number of ones in the binary representation. And then if there is only 1, 1, I know it is a power of 2, so it returns true. But if it is not exactly 1, then I return false. And as you can see, this is exactly the same solution to count the number of ones in the binary representation of a number. So what I do is that I have a variable count, and I check every digit of the number every time I check the rightmost digit of the number, and then if it is a 1, when I do the bitwise end, it becomes a 1, I add it to the count, and then I shift to the right to check the next rightmost digit. So this is the first solution. I'm going to run the code. Alright, I will submit the solution. Okay, this is working perfectly. 1 millisecond faster than 100% of Java submissions for power of 2. So I said before that we can do better. We can write a more concise and more efficient solution. So first, I'll show you that solution, and then I will explain to you how it works. So this is the solution. We can say return n is greater than 0, and n bitwise end n minus 1 equals 0. I will run the code. Alright, I will submit my solution. This is working perfectly. This is also 1 millisecond faster than 100% of submissions for this problem. So what are we doing here? How does this work? Well, this is how it works. Let's take a look at this. Let's say, for example, that n equals number 8 in decimal. So if we do n minus 1, what we get is 0, 1, 1, 1 in binary. So notice that this 1 became a 0, and all the other zeros after the 1 became 1s. And it will always happen like this. If we subtract 1 from the number, and if the number is a power of 2, this is what will happen. The first one will become a 0, and all the other zeros will become 1s. And then after that, if we take the original number and we do bitwise AND with this, with n minus 1, we have to do bitwise AND with this and this. So this is 1, 0, 1 bitwise AND 0, 0, 0 bitwise AND 1, 0, 0 bitwise AND 1, 0, 0 bitwise AND 1, 0. So we get all zeros. So if it is a power of 2, when we do this, we should get 0. And there's a special case that we have to handle. If n is 0, then it is not a power of 2, so it has to be bigger than 0. So that's how this solution is working. So if you like this video, please press the like button. Don't forget to subscribe, and see you next time.